Hello guys, happy to have you here, especially when we have lunch. So good to see you here. Today we'll be talking about how not to hurt yourself with ORM, specifically in Java with JPA and Hibernate. A few things about me. So I'm Karol, I'm tech leader and designer at Solers Consulting. In Solers Consulting we have Developers Guild and Java Competence, and I'm one of the drivers there. I'm fan of whatever makes our craft better, and fan of video board tabletop games. If you want to talk about it later on, then let's go for the after party and talk about it. For whom is this presentation? To manage your expectations, yes? So I assume that you used any JPA, Hibernate stack. You implemented some entities, associations, queries, and so on. And you had problems, or you were lucky enough to not have problems. And if you are master of JPA, Hibernate, and so on, treat this presentation as an opportunity to get back to strengthen your knowledge, but maybe I will surprise you with some new thoughts or sources. Okay, why do we do this presentation? Because according to AppDynamics, which apparently is a company that makes profit of fixing the problems with databases, more than half of application performance bottlenecks originate in the database. I would say that, or in the way we use it, yes. So on my projects up to this date, I believe that many bottlenecks originated in the database. And also, I believe that many mid developers, or even the experienced ones, lacked some behinds of JPA and Hibernate. So I want to get on the same page, and I hope you want it too, because you came here. So let's go into that. Also, why do we have these problems with Hibernate databases and so on? Because sometimes we do things just to make it work, not to understand it. So let's try to understand more. So how not to cuckoo yourself with ORM? In my opinion, we need to know entity states dirty checking, associations and loading, transactions and locking, and few traps that we have there. We will start with entity states and dirty checking. And to start with some code, who will tell me what's off here? I'm not hearing that. Anyone? Yeah, we have transaction here. Yes, we started transaction with transactional annotation, but we still save and flash on a repository, which is not needed here. And also sometimes not needed actions may lead to some problems. Why people do not know that save, flash, other not necessary actions are not needed there? How many of you have seen it? Like, really, raise your hand. Okay, that's why I'm showing it to you. I will get back to this picture, but we'll start from the basics. Why do we have transactions? Why do we have like entities working in these transactions? Why do we manage in transactions? So Hibernate follows the pattern unit of work. You can read about it in the patterns of enterprise application architecture by Martin Fowler, or on his blog. Sorry, I see that I'm not having the full image here. Damn it. I don't want to live with that bar. Okay, I will go with the full screen. Sorry. Let's go. Okay. Okay. Damn it. Really sorry for that. Okay, let's assume it will be good there. Okay, so unit of work is a place, let's say, in which we want to keep track of everything we need to do in some business case, in business transaction that needs to affect the database. So we throw everything we need to do, and then unit of work automatically should push the changes to database as a result of our work and clear everything. That's the pattern. And basically in Hibernate JPA, it works like that we start, we open the transaction, either manually or by some method, by annotation. Then we, like a master of puppets, we do some changes on the entities, and then we affect the database and then clean up the transaction. In code, it will be something like that. Yes, we need to have the entity manager or session from Hibernate or annotation transactional. Then we can manage the entities. We can do some operations on Java level, some streams, some transforms. What do you need? And then we have on the wrap-up. So either when we close the transaction or it closes itself with the end of method block, we have SQL generation, flash, commit, clear. So we push things to database and then forget that anything happened. Yes, that's the transaction. In case of entities management, we are going back to this picture. So entities can be in 4. It depends on the framework really, but in JPA Hibernate we have 4 states: transient, persistent, it's also called managed, removed, and detached. So if we have new object, it's transient, it's transparent for the transaction. If we start the transaction, create new object, it will not be saved to the database until we persist or merge it. Then our tool, our Hibernate JPA, is observing the entity, so it's persistent managed. Then we can detach it from the transaction, so it will be again transparent for the transaction and garbage collector will take care of it later, or remove, so if it were earlier on the database, it will be removed after the commit. So what I want to say here, remember that in the unit of work, we actually have some states, yes? So every entity that you create, is it entity because it has annotation on it on the class? Yes, but because we do something during the transaction. Either we find existing entity on the database or create new with persist merge. Okay, so the simplified graph, we find or persist new entity, we work on some table on our transaction, we can remove or detach, and it will also update the entity if we update, not remove, yes. Okay, but where are managed entities held? Because it's not that simple. We have something like persistence context. It's an object that is being created. I will tell you where. We have few other objects. Entity manager factory, that is like long-lived object that we don't want to create every time we do something in our application because it's costly to create that. So it is most often created upfront for the whole application. Entity manager, that is more short-lived one, and with entity manager we can have the transaction. And for the transaction, for the entity manager, during transaction, the persistence context is working. And what does it mean? That persistence context will track every entity during the transaction. So either you create it, persist it, update it, delete it, it will be in persistence context. The persistent context is in the first level cache during transactions. And that's important because if you query data to the transaction and then you want to query again for some specific data that you already queried, the persistence context will return already queried data. So it will always return you the thing that it already has. Context never forgets until the transaction ends, or you make it. So flush and clear may make persistence context to forget something, and also once the span of the transaction is finished, based on persistent context, we have SQL statements being run based on the content. So how ORM knows when entities changed? So we create the entity, then we save it, and what does ORM do with that? Yes, we have something like dirty checking. Some people does not know about this this mechanism, but it's really important in the whole ORM idea. And it happens on the transaction wrap-up. So after we do all the changes in our entities, the dirty checking works at the end. And how does it work? So we have managed entity in the persistent context. So either we create new or find entity from our database. Then Hibernate creates snapshot. That snapshot takes memory. Yes. Then we do some operations. We edit the entities. We remove them, and so on and so on. And then we have transaction wrap-up, and then the state snapshot is compared to the actual current state of the entity. And the process continues, yes. But what are the consequences here? Here we have some simple code. We have annotation about transaction. So this whole method is in the transaction scope, and after it finishes, the transaction is finished too. We find all products, and for all products in some loop, we update prices, for example, yes. What is the consequence? Even if only one property of a single entity, so even one product is changed, Hibernate will still check all managed entities. And additionally, state snapshots take memory. So in case of using dirty checking and using ORM, you are using more memory because we need to have the state snapshots. Also, the dirty checking is a process, so it takes also some resources to do the dirty checks, yes? And this is the number of dirty checks done on Flash. So it's a sum of every property per every entity. So maybe it will be useful for you in the future. So how to avoid problems while dirty checking? First, and the most obvious one, don't overquery entities data, yes? Only query the things that you need. If you need to change price for 5 products, don't query all, yes? Simple as that. Also, you can use projections for read-only. If you need read-only, if you have case only for the read-only objects, you can use entities with transaction that can be configured to be on read-only mode. Also, we can use object arrays or tuples, and also data transfer objects. Objects and tuples for the results of your queries, for the projections. They are losing some business context, yes, while querying because we have just plain data. So DTOs per case are a good option, but depends on the case. So after this description, I hope you are not that guy. And let's go to another block, to the associations and loading. I want you to remember that quote. It's from Java Persistence with Spring Data and Hibernate by Katalin Tudos. I will be recommending the book later on. Also, every resource that you have here, you won't miss it. I will be giving you the presentation as a QR code on the end. So you can just focus on the presentation, not on writing some things. Okay, so the truth is that you can write a sophisticated application without ever mapping a collection. That's hard to believe because we use ORMs to actually associate some collections with other entities. But that also has consequences, and I will show you some of them. So how many types of association do you know in JPA? Like that's a simple question. You can just shout it. Sorry? Yes, and? Okay, so 3 or 4 depends how you count it, yes? It's simple. But in how many ways can you program it? That's another case. Okay, that's just some of them. There are some keywords as unidirectional, bidirectional, join tables, value types. Unidirectional, reference only on one side of the relationship, so it's the most natural way as we have it in the databases. Bidirectional, so we have navigation properties to both ways, yes, so employee has company and company has employees. Value type, it's another thing. We can do such things as embeddable basic types or element collection with it. I won't be going into the details on that, but we can use embeddable as a composition of few properties inside another class. Embeddables doesn't have the identity on itself, just the entity that owns them. If you want to use element collections, think 10 times because they're not too performant. Yes, in case of managing bigger collections, they are really troublesome, and think twice about them. Okay, but why is it important how I model? Yes, why the quote said that maybe we don't need the associations? Because ORM can do things like not planned join table. For example, we have company entity and one-to-many employees. So one company, many employees. And that's the only mapping we have for that association. And what Hibernate is going to think about that? Okay, we don't have the second side of the association, so let's do a join table. Wow. And I know that probably you don't use Hibernate for DDL for creating your schema of database and so on, because you shouldn't. Please use Liquibases and other stuff that are meant for that. But Hibernate will expect something like that. Also, in that case, in case if we want to persist a new employee, it will do many unnecessary queries instead of just, inserting thing. So be sure what your association will do, or Git blame will find you. Another thing, we have another association, like one-to-many, many-to-one. Now we mapped both sides, yes? So Hibernate will not create any join table and other magic stuff. But do we really need two sides of the association? we have company with employees and employee with company. Like, probably it's the first thing you think when also I think when modeling association, let's do it both ways. But maybe unidirectional many-to-one association would be enough for our needs, maybe. Because if we have company with many employees, fetching the employees will always be troublesome, even if we have eager or either the lazy loading. We can, if we have only one side of the mapping, we'll never trigger the lazy loading because we don't have what to trigger it on. And we can use query for getting more records. So not always we want the both sides navigation. And I said something about lazy loading, so let's go into details. Fun fact, now by default in JPA Hibernate, we have lazy always when the second term in the association is many, yes? One to many, many to many is lazy. But it was not always like that. Hibernate until the version 5.0 used lazy for everything. Fun fact. But the JPA specification tells otherwise, so they changed it. But what does lazy loading really mean? If you have fetch type lazy, it is here by default, so we don't have that annotation. It will only hit database when we need to use the associated object. Yes, so we don't have that until we really use some data from that object. If we only get that object, it will result in proxy, and that's also fun fact that Hibernate doesn't query the whole object up front. He uses proxies, sometimes bugs, yes, to have place prepared for the data that will be loaded later. But again, to the eager loading now, it selects data together with the main entity. So always when employee will be fetched, the company will be also simple. You may find some sources in the internet or in the literature that lazy is suggested as a rule. Probably you know that that's not always the case. I gave you the example with one-side association. We don't want to leave our application with option to query thousands of people for the company. Yes, we just don't want that. We want to have the control on that. But on the contrary, should we use eager for all? Probably no. It depends always. But what is wrong with employee having company in eager fetch type if company is just one object? Think of the moments when you need to fetch a larger amount of employees. They will always fetch the companies too. Company may be large, yes, so maybe we don't want to fetch them. So make the decisions wisely. Don't say, oh, do lazy, or oh, do eager. Just per case design. Okay. I will jump into some popular, maybe not for all people, problems. So we have lazy loading first. And we have such a code that for all employees will have the company asked for the name. And let's assume that company is lazy. Yes, lazy associated. Do you know the name of the problem? have you heard about N+1 problem? So it is like the maybe most well-known problem for the lazy loading, as we can have many things loaded for the one entity when we use the associations. That's a simple case because we have only one object that is taken for every employee, but think of cases when we have the collections of objects. How to find N+1? Because, you know, we are smart. Yes, we know how N+1 works. We know how to omit it on the code review and so on. But what if we have legacy system and we don't know if there is some bottleneck or not based on N+1 problem? You can always turn on the logging, search for such logs, and okay, yeah, I found it, great. No, we have better tools for that these days. For example, we have some library, Spring Hibernate query utils, that can help you to find automatically the N+1 problem. The problem with that library is that you need to have the integration tests, so it's not for all the projects. But having it in the dependencies, setting some properties, running the tests, and you have information about where the N+1 can be found, and then we can fix the places. I will show you in a minute how to fix them. Also, we have DB utils in the repository Hypersistence utils by Vlad Michalcia. Vlad Michalcia is the boss of all Hibernate on the world. Let's assume he's Java champion, and he wrote a very successful book on Hibernate and on performance of Hibernate. I will be recommending that later on, but he will be in this presentation a lot. Okay, how to fix N+1 problem in Hibernate, in JPA? We can use join fetch clause in native query. So for example, we can write such a query that will join fetch things on the go. So we don't get the Hibernate to generate some bullshit. Okay. Also remember that if you have read-only, use DTO projections or other projections. Also, we have entity graphs. It's a very interesting API from Spring, which allows you to fine-tune your queries. So per entity, you can say, okay, this thing I want to query lazy and this thing eager and so on, even if the mapping is another way around. I recommend to go into entity graphs. It's a fine tool for that cases. Also, we have batch size. It is not really like a great solution, but maybe in some cases it will be feasible. So we can say, okay, query me only the 10 things at once. So we won't have such a bottleneck as normally. Okay, and fun fact, Spring Data JTPC started to support single query loading. Don't mess it up with SQL, it's not that. And for the CRUD repository, some methods are omitting N+1 by default. So there will be future versions on that, so it's good to observe it. Maybe one day we will not have N+1 in Java. Okay, another fun fact, in .NET we don't have lazy loading until we specifically turn it on in the properties of our application. So they don't have lazy loading by default in applications. Okay, but if I do only eagers, what can be the problem here? We have company, We have list of employees, list of offices. What if I query the company with all the things? What problem can we have? Some names of problems. Do you know? There can be problem with Cartesian explosion, or named another way, Cartesian product. Basically, for all these entities, we'll have not necessary records with all combinations of the data. We don't want that. It's overhead, it's affecting performance, affecting basically everything, yes? It's not so easy to fix that. Use design, of course. Or you can, maybe you don't want to query everything at once, but if you want, the solution is to remove one side of the association, select parent entity separately, and then run queries for the collections. For example, like that. We find the company and then run queries for the other collections. That solution works. It doesn't give you not necessary combinations, but if you have many of the collections and data, you will have to write many queries. So the design is the king. I love this meme. We don't use ORM to fix things with SQL, but we do. But Vlad Michalcia said in his book that native queries are unavoidable in any non-trivial enterprise application. For now, in my applications that I was part of, yes, it's true. I don't know. I didn't see another like other applications that uses only ORM and are on production. Maybe I didn't see the CRUDs and so on, but native queries are powerful. And let's get back to the truth of Catalin. Always make sure you actually need a collection. Okay, and the last big part, transactions and locking. So we'll go into optimistic locking because for the web development, I believe it's the most useful option because it doesn't affect your performance as pessimistic as it only affects the business side. And if you model everything quite good, it makes a good effect. So to enable optimistic locking in Hibernate, you need to annotate something with version, either the entity or some field in it. Without it, Hibernate will work with last wins manner. So if we fetch some data and our colleague fetch some data and I update the database quicker, he will be able to update the data even if I was quicker. So he won't see my changes, yes? It looks like that, for example. If we have something like that, every time we load the entity into persistence context, when we do dirty checking and so on, Hibernate will check if version changed, yes? So if somebody changed that on the database version is higher, then we have optimistic lock exception. And optimistic lock exception, naturally, for me, is related to aggregates from JDD, because with entity version, some logic for the guarding the consistency, we are able to model JDD aggregate with Hibernate. And I won't be going into the JDD, but if you have domain, if you have modeled the aggregates correctly, you will not get too much optimistic locks, but maybe if you have too much optimistic locks, maybe something is off with the boundaries of your aggregate or domain, and etc. Okay. Also, if you go into aggregates on Hibernate, remember about the property optimistic force increment. That helps you keep track of changes to the children of your aggregate root. So it's really important to remember about that when you model aggregate in Hibernate. Some tips, some easy tips for the last few slides. If you have transaction, don't pass entities between two transactions. They are managed only in the way, in the one they were loaded or saved. So don't pass entity that you loaded or saved in one transaction to another one, because it becomes ambiguous which transaction should update it. Yes, one fails, another succeeds, everything is messy. Yes. So if you want to eventually pass something from one transaction to another, pass IDs or DTOs. Let the transaction load the data for itself. And that's the last one. What could go wrong with that code? So we have transaction. We are finding the company by company ID. We are setting the name, and then we are dispatching event. Company's name has changed, folks. What could go wrong? What is... Yeah, so if transaction is rollbacked, so the exception is thrown or something, on the end of the transaction, the event is still dispatched. So we don't want that. We don't want to say, hey, name is changed when it isn't. So how to go with that? First thing, we have something like transaction bound events. So we send event on, we dispatch event only if the transaction finished. But also there is a pattern that I also like. I use it on my project and so on. The outworks pattern that says if you have something bound to the transaction, maybe you should operate on it separately. So, for example, we have a request for the email, and we save it in another place than the transaction, than the result of the transaction, but in the same transaction. So we say, okay, if this transaction passes, I will have a request in my database, and then I will have to take it by another mechanism, another queue, other dual propagation component with separate life cycle. So yes, so we can handle it later when the transaction we know the transaction finished successfully. If you want to know more about Outbox pattern, I really recommend the Better Software Design podcast as whole, but also in 7-8 episode we have the episode about Outbox pattern and successful communication. So really recommend this. That's all of the materials I prepared, but now I will list some sources. Maybe you will find it useful. If you have enough of the Hibernate JPA, you want to stick to something else, you can use Juke. It's a library that you can use instead Hibernate and JPA, or plain Spring Data JDBC or with JDBC template. There is no dirty checking, no lazy loading. Everything is updated at once. We can have the fine-grained control. Maybe it's heaven, maybe not. It's for you to decide. In case of sources for that, there is some example in DDD by examples in Cinema project by Jakub Pilimon. There is also a great talk by Simon Martinelli about do you really need Hibernate, and as an alternative there is Juke. Also, I link you some differences in performance in case of Spring Data JPA versus JDBC, so you can decide if it's worth changing. In case of books, Catalin to those Java persistence with Spring Data and Hibernate. I can't stress it enough. I really like authors that make their books, their articles easy to read. And that's the book that's really easy to read. Maybe it has 600 pages, okay? But I really enhanced my knowledge about the JPA and Hibernate with that book, and I totally recommend it. Also, our beloved Vlad Michalcia in 2015 created a high-performance Java persistence. If you like the low-level stuff, if you search for high performance in your JPA Hibernate applications, this may be the book for you. But as we know, software developers not always like to read books. So I have other sources. First is documentation. It's really readable for me also, so I like it. I use it several times, doing some trainings or just using during my application implementation. Also, another great guy, Torben Jansen, I don't know. His blog is also very readable. It's easy to read. He has great examples, but you just read it and you know it. Sometimes when you read Vlad Michalcia's blog, you don't know what he's talking about. So Torben is easier. And also I really recommend his newsletter. It's awesome. I am really happy that I can read him. And he really sends the newsletter like once per day or per 2 days. So it's really quick mail, but some knowledge. We have new knowledge from that. 2 videos in Polish. Jakub Kubryński, JPI, Beyond Copy-Paste. It's a great talk about transactions, loading, and so on. Also, Wojciech Oczkowski about just transactions, and that's a great talk. I really recommend it to see. And also Vlad Michalcia again with some tips, some low-level tips that you haven't heard here because we weren't going to the deep dive. So I recommend those 2. At this QR code, you have firstly survey that you can give me a review. There are only 3 questions, so it's really simple. Only 1 is required. So it's like 1 minute, 2, 3 if you want to spend more. Also, in this survey, you have link to the presentation. So you have all the resources that I showed you, that I've shown you in the presentation there. And also, I encourage you to review me on the application that is used on this conference. And that's all. Thank you.